Hello everybody and welcome to this lesson. In this lesson we are going to talk about the filter effect component transfer. This effect is again a little bit more tricky than the rest, but have patience and I'm sure that you will be able to learn it. What the function basically does is you have various functions which manipulate the red, green, blue and alpha channels. It either amplifies it or suppresses it depending on the initial color. I'm going to go in more detail in a moment. First of all, let's see what kind of functions we have. Here we have red and we have 5 possible functions: identity, table, discrete, linear and gamma. And for green I have the same 5 functions, and for blue and alpha also the same 5 functions. Identity is the easiest to understand. Identity is nothing happens. So the amount of red in the first image is exactly the same as the amount of red in the filtered image. Next, I'm going to talk about linear and gamma, and then I will talk about discrete and table. Let's have a look at the presentation I made to explain this better. Here we see 2 functions. On the left we see the linear function and on the right we see the gamma function. On the x-axis we have the input color value and on the y-axis we have output color value. The red line shows the relationship between the two. So in other words, what we do if we want to find out how much red the output color has, then we go to the input color. Let's say there's no red at this particular part of the picture. Then I go to 0 and I look. That corresponds to a bit less than 60. Any area in the picture, in the original picture where there's the red component has a value of 100, I look at this graph and I see that the amount of color in the output picture will be 120. So up until here we are amplifying the amount of red. If I look at the 250 line, so in the part of the picture where the red component has a value of 250, we see that the output color will be around 235, which is less. So in 250 the amount of red is suppressed. I can define this line with 2 parameters, and that's the intercept and the slope. The function of the line is given like this. O is output is equal to the slope multiplied by the input plus the intercept. Those of you that are good at maths will immediately recognize this line. The intercept is this part, the place where the line intersects the y-axis, and the slope is the steepness of the line. If I increase s, the line will be steeper, and if I increase c, the line will shift upwards. I can also give a negative value for c or a negative value for the s, in which case the line will be sloping downwards. As for the function on the right, similarly to the linear function, I can look up the output value as a function of the input value by using this table to look it up. The function for this line is given by the function O, output, is equal to the amplitude multiplied by the input to the power of the exponent plus the intercept. And how do these parameters A, E and C affect the graph? Well, intercept is easy. intercept just shifts the whole graph up or shifts the whole graph down. As for amplitude and exponent, looking at the next slide, I see that what happens when I change the exponent. For example, I have an intercept of 0 and an amplitude of 1, and the blue line shows what happens when I have an exponent of 1. It's just a flat line. If I have an exponent of 2, there's a certain curve to it, and if I have an exponent of higher than 2, the curve gets more and more. So for example, in the case of an exponent of 4, all the color is suppressed until I get to about 60, where it continues suppressing it, but with less and less amount until 100% of the red remains. So if I have parts of red with 100%, 255, then it results in a 100% red in the output. Any part before that, the amount of red will be suppressed. If I change the amplitude, it just shifts the graph up or down. Here I have an example with an exponent of 2. If the amplitude is 0, the whole graph is multiplied by 0, and it just removes all the red, no matter how much is in the input picture. If I have an amplitude of 0,5, it takes this graph and just halves it, and then that results in this red line. Here, if I have an amplitude of 1, it stays the same as this black one here. And if I have an amplitude of 2, it doubles it, but it cannot exceed 100%. So if it exceeds 100%, it just remains at 100%. Next, let's talk about the discrete and table functions. To the left we see the discrete function, and to the right we see the table functions. We see that we have a number of height values as input, and we see that on the discrete function it defines a series of plateaus, and on the table function we define a series of straight lines. Notice that the width of these plateaus depends on the number of heights which we input. So we can put any number of heights. In the case of discrete, if I specify 5 heights, the x-axis will be split into 5 plateaus, each of the same with the same width. In the case of table, if I specify 6 heights, the x-axis will be split into 5 plateaus again, because I need 2 heights to specify the 1 plateau. In the case of discrete, I should start specifying the first height, then the second, then how many ever I want, and I should always end by typing 1. This one doesn't really have any effect on the function, only to let us know that the function is over. As for specifying the table inputs, we just specify the number of heights. So this is quite an abstract topic. I hope you understood it a bit. If you don't really understand it, try watching the video again, or there's some further reading you can do at this website, which explains it in a bit more of an exact way. Or alternatively, you can finish watching this video where I'm going to do a couple of demonstrations in Inkscape. In order to demonstrate the component transfer functions, I first created a couple of gradients, and the gradients are going to start on the left have no red component at all, and on the right they have 100% red component, and in between it gradually becomes more and more. The other components, I did not include them just to avoid confusion. So let's go to this component transfer and let's have a look at the identity. The identity does absolutely nothing. Next, let's have a look at the linear function. Here I have a slope and an intercept, and you can see that as I increase the intercept, the red component increases more and more. If I decrease the intercept, the red component decreases a lot. If I increase the slope, we see that the red component is amplified more and more later on. And if I make a slope of -1 and set the intercept to 1, I see that I've reversed the direction of the gradient. Next, gamma. If we change the amplitude, it increases the amount of red component. If I increase the exponent, we see that the red component is suppressed more and more the further we go to the left. And here we have the offset. The offset is just the same as intercept. Next, let's have a look at discrete. As for discrete, remember that we have to specify a number of heights. We specify it as percentage, but not as percentage, but percentage divided by 100. So 100% corresponds to 1, 10% corresponds to 0.1, and etc., etc. Here we want our first height, for example, to be 0, the second height to be 0.1, 10%, the third height to be 90%, and that should be the last height, so we have to end it by typing 1. And here we see that we've divided the area into 3 discrete sections. First, the amount of red in the first section, the amount of red is 0. In the second section, the amount of red is 10%. In the third section, the amount of red is 90%. I can add an extra section, for example, with 50% red. And here we have the fourth section has 50% red. As for specifying a table gradient, I'm going to show it in another filter. And here I specify the first height will be 0 and the second height will be 0.5 and the third height will be 0.5 again, and the fourth height will be 1 for 100%. And here we see that we've divided the group into 3 sections. The first section jumps from 0 to 0.5, and there's a gradual gradient from 0 to 0.5. The section stays at 0.5 until the section is over, and the last section there's a gradient from 0.5 to 100%. So thanks for watching. See you in the next exercise. Bye bye.